All right, so another thing on the coordinate geometry is parallel and perpendicular lines. So this is parallel. Consider the blue and orange line below. So let me get my laser pointer. Where is it? The blue and the orange line. We're looking at these two. And suppose that they have gradients m is equal to m1 and m2 respectively. So the blue line, the gradient for the blue line is m1, and then the gradient for the orange line is m2. Parallel lines have the same gradient. So if the blue line and the orange line are parallel, that means that their gradients are equal. So m1 and m2 would be equal. m1 equals m2. In this case, remember the general equation of a line. Y is equal to mx plus c. Looking at the blue line, we could see that the equation is y is equal to half x plus 5. And by looking at it, can anybody tell me what the gradient is? The gradient is m. So looking at that equation, can you tell me what the gradient is? A half. Good job. Now looking up here, the orange line, the equation of the orange line is y is equal to half x plus 2. So looking at this equation, can you tell me what the gradient is? On this m2, a half. And m1 is equal to m2. m1 is equal to m2, right? Yeah?
Yes.
Yeah. Therefore, these two lines are parallel. They are parallel because their gradients are equal. And that's it. Let's see that one. Okay. So you might find questions like these. They'll give you the equation of two lines and then tell you to state whether they're parallel or perpendicular, or they could tell you they're supposed to be sure that these lines are parallel. Anyway, they could ask you to show that it's parallel. So in this case, they want you to show that it's parallel, right? The first step is to put each equation in the form y is equal to mx plus c. This is my first equation here. Two x plus 5y is equal to 7. And remember, we want it in the form y is equal to mx plus c. So what we're trying to do, make y the subject of the formula. So that's why we have 5y is equal to 7 minus 2, y minus 2. We have to subtract subtract 2x on both sides. So 5y is equal to 7 minus 2x. 5 multiplies on this side, so it divides on this side. So you could say divide 5 on both sides. Y is equal to 7 minus 2x on 5. That's just basic transposing, right? If anybody didn't know how to do that, confused about how anything here, let me know. Okay. This could be broken up into fractions. So y is equal to 7 minus 2x on 5 could be written as y is equal to 7 on 5 minus 2x on 5. But remember, we want it in the form y is equal to mx plus c. So that's why I put y is equal to minus 2 on 5. So minus 2 on 5 is my gradient, x, plus c in this case is 7 on 5. So everybody understands that? How I got y is equal to minus 2 on 5x plus 7 on 5?
Yes, miss.
All right. And then my next equation, 10y plus 4x plus 5. Same transposing, we're trying to make y the subject of the formula to get it in the form y is equal to mx plus c. So 10y, I carry across the 4x and the 5, so 10y is equal to minus 4x minus 5. This is just transposing, right? 10 on this side, divide on this side, so y is equal to minus 4x minus 5 on 10. We could break up the fraction. So minus 4x minus 5 on 10 is the same as y is equal to minus 4 on 10x minus 5 on 10. But minus 4 on 10 and 5 on 10 could be reduced, right? If we divide this by 2, we'll get minus 2. And if we divide this by 2, we get 5. Divide this by 5, we get 1. Divide this by 5, we get 2. And that's why I had down here, y is equal to minus 2 on 5x minus a half. So everybody understands how I got that equation? This one. Yes, no, confused? Understand?
Yes, miss.
Okay, just need to make sure. Okay, the next step, what you want to do is identify M1 and M2. So these are the two equations we came up with in the form y is equal to mx plus c. I'm gonna keep writing it here to make sure you remember y is equal to mx plus c. Let me write these underneath. Y is equal to minus 2 on 5x plus 7 on 5. Y is equal to minus 2 on 5x minus a half. So by looking at this now, we could say that M1 is minus 2 on 5 and M2 is also minus 2 on 5. Everybody understands how I identify the gradients, right? By just looking at it, I could identify the gradient. Understand? Everybody understands how I identify the gradient.
Yes, miss.
Okay. So M1 is equal to minus 2 on 5 and M2 is also equal to minus 2 on 5. The third and final step is to show that the lines are parallel. We said parallel lines have the same gradient. So since M1 and M2 are equal, M1 equals M2, then we could say that these lines are parallel. Right? Let's do some more questions. Okay, I have a past paper question. Hold on. Okay, let's do the third one first, and then we could go back to this one. So the third one. We'll do this one together, and then I'll let you try the others. So I have the lines y plus 5 is equal to 2x. That's one equation. And then I also have the line y is equal to 2x plus 7. The first step is to write it in the form y is equal to mx plus c. Y is equal to mx plus c. We could tell that this one over here, is already in that form. So no need to do anything with it. It's fine. This one though, that it's not in the form y is equal to mx plus c. So could anybody tell me what I would put here now if I wanted in this form?
First, you will carry across the 5. Well, minus 5 from both sides. So it will be y equals 2x minus 5.
Y is equal to 2x minus 5. Good job. So now we know that these two are the equations we're looking at. Right. The second step, I want to identify M1 and M2. M1 and M2. Looking at this, can anybody tell me what's M1?
2.
2. And M2 is also 2. And now the third and final step, to show that they are parallel. Parallel lines, the gradients are equal. So M1 equals to M2. In this case, M1 is equal to M2. 2 is equal to 2. And that's why you'll put M1, here and this in a different color. Oh my. This is actually what you should put, like this exact statement. M1 is equal to M2. Therefore, these three dots mean therefore. It's a symbol in math. So therefore, the lines are parallel. You should write out the word, but in this case, I'm gonna just put two parallel lines. Everybody understands that, right?
Yes, miss.
Okay. You should always put this last line, eh? If they ask you to prove it, you need to say that since these two are equal, they are parallel. All right, eraser. I want you to do this one of it. What 8y is equal to 3x plus 16. That's my first equation. And then my next one, 8y plus 16 is equal to 3x. I want you to show that these lines are parallel. So let me know when you finish that. Anybody finish?
Yes, miss.
All right. So I'm gonna just go through it now. Y is equal to mx plus c. First, we want to write them in this form. So looking at this first one right here. What would I write? Y is equal to what?
3/8x plus 16/8. And you could simplify the 16/8 to get y equals 3/8x plus 2.
Good job. And the next one, what would y be equal to?
3/8x minus 2.
Minus 2. Everybody understands how we did this, right?
Yes, miss.
All right. So what is my M1 and what is my M2?
M1 is 3/8 and M2 is 3/8.
So both of them are equal, right? What's the statement that we'll put in to show that they are parallel?
M1 is equal to M2.
And y is equal to M2. Therefore, I'm gonna just put the parallel. They are parallel. Everybody got this, right?
Yes, miss.
All right. Yeah. Let's do the class people question now. You can see this, right?
Yes, miss.
All right. So looking at paper 2, 2018, 3 part B. They want you to determine whether they are parallel lines. Okay, so you could do that and tell me when you finish. All right, so can you tell me, are they parallel or not?
They're not parallel, miss.
All right. I'm good for that. Can anybody tell me what you got for the gradient of this line? This line. What you get for the gradient of this line?
I got 1 as the gradient.
Okay. You got 1 as a gradient, right? Let's go through that just now. And 3x minus 2y. So it's a minus 3. What you get for the gradient for this one?
-3 Wait, miss, for the first one, wouldn't it be -1?
Yeah, that's why I said I would go through it. All right, so first we want to put it in the form y is equal to mx plus c. So what would I write here? Y is equal to what?
negative
Anywhere.
x plus 4.
Plus 4. Answer this one. Y is equal to mx plus c. So what is y equal to? Actually, let me do this one step by step. Don't want to confuse anybody. So 3x minus 2 plus some minus 9 is equal to minus 3. So we could carry across the 3x. Is 2y. This becomes minus 3 minus 3x. We divide this side by minus 2. So that's minus 3 minus 3x divided by minus 2. Remember, you can break up the fractions. So this is the same as minus 3 on minus 2. And then it has minus 3x on minus 2. If I put this sign, I want to show you. So you know minus and a minus is a plus, or you could say the minus is cancelled. So I end up with y is equal to 3 on 2x, because I want it in this form. So that's why I put 3 on 2x here. Minus is cancelled, so I get plus 3 on 2. Everybody got this equation?
Yes, nice.
All right. This equation.
Also, nice. May I be excused for a moment, please?
Wait, repeat that. I can't hear.
May I be excused for a moment, please?
Okay, no problem. All right. Now we have to identify M. What color do I? Okay, M. M1 in this case. Can anybody tell me what M1 is? Anybody tell me what M1 is? All right, I'm just put the minus 1. And then in this case, M is equal to 3 on 2. M2. However, unlike the other cases, M1 is not equal to M2. So these lines are not perpendicular. You can still hear me, right? Because it's raining. I don't know if you can hear me. Can you hear
Yes,
me?
miss.
All right. So what you'll put, M1, this is your final statement, then. M1 not equal to M2. Therefore, these lines are not parallel. Everybody understands that, right? Why they're not parallel?
Yes, miss.
All right. Okay, let's start the other ones. Okay, so what I realized, remember that alpha, beta test, so sums and products of roots. I put one trick question there. It was the one with alpha minus beta squared. I didn't do that specific one with you because I wanted you to use your prior knowledge. So all that we went through in class to try to figure this out. But it seems that most people started panicking after they saw something that was unfamiliar because only one person got it right. Okay. So I need to make sure that you don't get used to, yeah, I gave you these steps. So step 1, 2, 3, just follow the algorithm and then you could solve anything, right? But that is not always the case. you would have to use your prior knowledge, so everything you know, to try to solve that question. Try to solve a question. We'll look at this another time. And that's why I have these questions, these rooted problems. It's not straightforward like the others. It requires you to use your prior knowledge and try to solve it, but that's okay. It doesn't matter how complicated, how complex a question is. If you know what you're doing, you could solve it. Okay, so don't get scared. Okay, number 6. A line P is parallel to the line represented by the equation 2y plus 5x plus 3 is equal to 0, and passes through the point minus 2, 4. And they want you to find the equation of P. Before I go through this with you, I want you to try it on your own and tell me what you get for the equation of P. Remember all that we did so far? We learned to find the gradient. So I'm gonna just put m is equal to whatever. We learned to find the equation of a line. And now we learn in parallel line. All right, now. So now what I want you to do, use your prior knowledge and try to break up this quote unquote complex question into something you would be able to understand and something you would solve. Remember, ADMAth is an analytical subject, requires you to think. Okay, so try to find the equation of P. Anybody finish yet?
This one, 7.
Oh wait, no, just do 6, just do 6.
Oh, okay. Well, yeah.
All right, that's one person. Anybody else finish?
Yes, miss.
Nice. 2 people. Anybody else?
Yes, miss.
Oh, Tracy. Okay, I see. All right, so they told us P, a line P, parallel, these lines, that means parallel, to another line, which has the equation 2y plus 5x plus 3 is equal to 0. Okay, so the first thing, if P is parallel to this line, remember that means that the gradient of P, so I'll name that P1, must be equal to the gradient of this line, name that M2. Remember that, right? So, and we knew this, and we already know about this, that if lines are parallel, that the gradients are equal. Yes, no? And you already knew this, right? See, using what you already know, and even the most complex questions would be simple. So we know that the gradient of P would be the same as the gradient of this line. So what we have to do, first we find the gradient of this line. Remember, we always need it in the form y is equal to mx plus c. That's the only way we could find the gradient. That's the x. But let me just erase it. Mx plus c. So what is y equal to in this case?
Negative 5 over 2x minus 3 over 2.
2x minus 3 over 2. And what's the gradient of this equation? Of this line? Looking at this equation, what's the gradient?
Negative 5 and 2.
It's 5 on 2. Hold on. Let me name this M1 and this one. Right. So M1 is equal to minus 5 on 2. And we said that P is parallel to this line. So that means the gradient of P is also equal to minus 5 on 2. So M1 is equal to, M2 is equal to minus 5 on 2. And we know all of this so far? And we did all of this?
Yes, miss.
Most complex questions to be broken down into simple bits you can understand. And all we have to do now, gosh, I need to erase some of this. It's okay if I erase it, right? Right?
Yes, miss. Yes, miss.
All right. Right. And they also told us that P passes through the point minus 2, 4. And we already know how to find the equation of a line given a point and the gradient.
Yes, miss. Yes, miss.
Exactly. So which method do you want to use, the first one or the second one?
Second one.
So this one, y is equal to mx plus c.
No,
Or the
the, well, then the first one.
All right. Y is y1. Y minus 1. Next one. So you put back your y. Y1 is 4. M minus 5 on 2. Put back your x minus x1. That's minus 2. Y minus 4 is equal to, this is minus 5 on 2. Remember, minus and a minus is a plus. So now in brackets, I have x plus 2. I could expand these brackets. I can expand these brackets to get y minus 4 is equal to minus 5 on 2x, 2x minus 5. Y, so this is just making y the subject of the formula now. This becomes plus 4, so it's minus 5 on 2 x minus 5 plus 4 is minus 1. And that is why this is my answer. Everybody understands that?
Yes, miss.
See? And that goes for any subject, eh? No matter how complex the question looks, use your prior knowledge and you could do anything. Break it up into simpler pieces that you understand. Oh gosh, we need to leave and rejoin it. Okay, so you can leave and rejoin.